Hello everyone and welcome to today's video. This is going to be a very short video on the 5 simple organic reactions that we covered in class towards the beginning of the first unit. You know, they are called simple reactions. That doesn't necessarily mean they're easy. Just in terms of all organic reactions, these ones are relatively simple, not very complex. The important thing to remember when trying to do an organic reaction is to recognize the functional group present. If you don't know what the functional group is, you don't know what type of compound this is, it'll be very hard to do the reaction. So recognizing functional groups is an important first step before you tackle organic reactions. This first reaction here, this is the functional group of a carboxylic acid, the double bond O and the single bond OH at the end of a molecule. It's reacting with a ethyl group and an OH. OH is an alcohol. So a carboxylic acid plus an alcohol will give me an ester plus water. The acid loses the hydrogen and the alcohol will lose the OH. Together, they're going to form water. And then the two molecules that are left are going to join together at the place where each one of them is missing a bond. So this carbon here is going to join to this oxygen to create an ester. 1, 2, 3, 4, 5 carbons long. So this is 1, 2, 3, 4, 5 carbons long, a double bond oxygen, a single bond oxygen, and then a CH2 and a CH2. Sorry, CH3, my bad. This forms an ester, which is represented by the C double bond O, single bond O, right there. Now, it's regardless of what's attached to the rest of your compound. So the carbon chain itself remains unchanged on both of those, and they just join together where each of their functional groups has lost a bond. They're going to join up just to create each other's octets and make them full. The second one is an NH2 functional group. This is an amine and strong acid, HCl. One thing you can sort of note about all the simple organic reactions is that they're going to do one of two things. They're going to try to form water, like in this first example. And if they can't form water, the only other thing that's possible is the transfer of a hydrogen ion or a proton. In this second example, there is no OH present. There's no oxygen in these two molecules, so there's no chance of forming water here. So what happens is actually a proton transfer. The hydrogen from this HCl will attach to the nitrogen of the amine. And we get a positively charged product here, as nitrogen now has one too many bonds. It has four, instead of its normal 3. The chlorine is left having one less bond, so it gets a minus charge. The third example, again, is a carboxylic acid, a double bond oxygen and a single bond OH together at the end of a chain, plus a strong base. This one will kind of do the same thing. It's going to look to either create water or the transfer of a proton. This one actually does make water. The hydrogen, again, from the acid, the OH from the base will make water. Acids plus bases will make a salt plus water. And then they're going to join together. So sodium is going to join to that oxygen right where the hydrogen left. So we've got this sort of looking product here. Okay, so acid plus base gives you a salt plus water. The last two are the same type of reaction, only the temperature is the difference here. We've got a greater than 100 and less than 100. Greater than 100, this reaction forms an amide. Carboxylic acid plus an amine will make an amide plus water. The second, less than 100, is a proton transfer. So considering this OH on the acid and one of the hydrogens off the amine, that's going to make water. And again, the two remaining molecules are going to join together right where each of them has lost something. So this first acid is 1, 2, 3 carbons long. 1, 2, 3. A double bond O. The OH is gone. That nitrogen has lost one hydrogen, so it's missing a bond. It's going to attach itself to the carbon where the OH has left. So nitrogen, there's still one hydrogen remaining, and then there's a CH3 on the end. And of course, all these are hydrogens here. So this is an acid plus an amine to give us water plus an amide. And here's our amide functional group right there. Now, less than 100 degrees, the same reaction will only produce a proton transfer. The hydrogen from the acid will attach itself to the nitrogen, to its lone pair. So I'm going to draw both of these compounds. I'm going to do this first one actually as the line diagram. So there's our 3 carbons with a double bond O and a single bond O. The hydrogen is gone. And then the amine itself, CH3 and H3. The nitrogen gets one extra hydrogen. This becomes positively charged because it has one extra bond, and the oxygen here, this single bond oxygen, has one less bond, so it gets the minus charge. For all of these simple reactions, it doesn't matter what is attached to the carbon chain. It could be, 5, 10, it could be 100 carbons long. It carries through in the reaction, and the only thing that changes, or the only thing that's going to react, is the functional group itself. So you could make the compounds as complex or as simple as you like, as long as you're reacting only the functional group. They will always react in the same way. So give some of these a try from your workbook. This is actually a newer version of the workbook, which you don't have, so you may not see these exact same examples, but there are several examples in your workbook that you can try. And of course, as always, if you have any questions, feel free to ask. Come and find me, email me, ask in class. But definitely want to know these reactions for your upcoming quiz in a couple weeks. All right, that's it for this one. Good luck with your studying, and let me know if there are any issues or any questions. Until next time.